Welcome to Ask and Learn.
All right. So we have that X is the amount of new currency in circulation at time t. So for the problem, for part A, it says to formulate a mathematical model in the form of an initial value problem that represents the flow of the new currency into circulation for the given information. So since we have that X is the amount of new currency in circulation at time t, let's make the numbers simpler and assume that X is in terms of billions of dollars. Do you notice that there's an implicit assumption that the total amount of paper currency remains constant at 10 billion? So the maximum value that we have is 10 billion. Um and for that, since there are no new bills, because the max is 10 billion, t equals 0, and then we have that x of 0 equals 0. This is our initial value. Now we must find dx over dt, so the derivative of that, and recall that this is simply the rate of change of the amount of new entering the country. So we're assuming that every day 50 million is going to come into the bank. The bank then replaces all those bills with new ones. So when t equals 0, the 50 million of new bills replaces the 50 million of old bills. However, after that, some of that 50 million that comes into the bank is new bills. Because of this, we must figure out what percent of the currency is old bills. Notice that this problem is slightly different in that we do not have a rate in and a rate out. Instead, we simply replace all the incoming bills with new bills. So dy over dx, the derivative, depends on how much of the income money is old bills. Now, any given day, the change in new bills is going to be dx over dt equals 50,000, and that would be the percentage of old bills. So right now, does this match what we think dx dt should be at t equals 0? Um, is this matching with what the information we have? So above we have dx dt equals 50,000. Um, so then if I multiply that by 100, it would equal um 50 million. So matches what we reasoned out. Now we must figure out the percentage of old bills in the country. We know that the number of new bills is X, so the percentage of new bills would be X over 10 billion. Therefore, the percentage of old bills in the country is 1 minus X over 10 billion. Thus, we have dx over dt um, equals 50,000, 50 million, 1 minus X over 10 billion, and our initial value being 0. Given that, we move over to question B, and that says to solve the initial value found in part A. So this seems reasonable because as t increases, x increases slower. So this seems likely because as we have more bills in a new country, we end up replacing less old bills with new ones. And then moving on to C, to find how long it takes new currency to reach 90% of the total, we have to set x of t equals zero point 0.9 times 10 billion, which would equal 9 billion, and solve for t that way. So here I have laid out how you solve for it. Um, and for that, you would receive approximately 460.5, but since this is days, we got to round up. So it will take about 461 days for the new currency to reach 90% of the total amount in circulation.